Okay, so now we're going to graph another one. This will be my grand finale here. So what we're doing here, so we're going to look for that lead term. So we're going to say x squared times x times x. So we're going to get a lead term of x to the fourth. Okay, so a lead term of x to the fourth. So this is just a regular parent function of a quadratic, or a quartic, right? So the next thing I want to do is find my zeros. So I see that first one right there at 0. Okay. See another one over here at 3. Another one here at 3. And then I see another one over here at -2. So we got one over here at -2. So find your lead term, plot your zeros. So those are the steps. So now something that happens with cubics sometimes, or with polynomials sometimes, is we don't have enough zeros for the degree. So what we saw in the first example is we saw that the fourth degree, the quartic, could have 4 zeros, like we saw in the first example. But this one only has 3. So what happens here is we're going to have to kiss the x-axis on one of them and not go all the way through. So let me show you some examples. So I know my end behavior is going to have an arrow at the top on both sides. So I'll start on the left. So I'm going to take this, and let's just say that this is where it kisses. So it kisses the x-axis there, does its second wiggle there, and it does its last wiggle here. So that's one graph it could have looked like, right? So I have 1, 2, 3 wiggles, 4 take away 1 is 3, and then my end behaviors are the same as my parent function, right? Or maybe instead I want to wiggle, so still have my arrow here, right? So maybe it goes through 2, loops around, and maybe it kisses the 0 instead, okay? And then comes out like that. So it still has 1, 2, 3 wiggles, has the same end behaviors, right? I can still talk about domain and range. The end behavior didn't change. Okay, so I could graph it like that. Or I could kiss that last one instead. So I could say, okay, I'm going to go like this. I'm going to go through this one, and I'm going to kiss this one. Okay, so what you're seeing is we just don't have enough information to determine. So really, all I need to know is that you know what the zeros are. So remember that I grade these graphs with 2 things. So I gotta have the right picture. So that shows me the rate of change. This is a decreasing function at a decreasing rate, increasing rate, increasing, decreasing, and so on, right? But I also need to see its critical points. Well, its critical points are where y is 0 for all polynomials. So that's why I need to know that you know where these points are. But then from everything else, we're just going to go like normal. Hey, the answer for the domain question is always this, because I can put anything into this x. Remember, sometimes it's smarter to ask what the domain can't be. And in this case, it can be everything. So it's everything in the domain, the range. I minimum out at some min, right, that I do get to equal, but then I'm going to go to infinity, which I don't get to equal. Because this is an even function, it doesn't matter which way I send my x, the f of x will always, in this case, it's going to go up, and that's because I didn't have a negative in front. So this is how we'll graph all polynomials. So again, find the lead term, plot the zeros. If there's only 3 and you're looking at a quartic, then one of them has to kiss and not go through. Okay? If I'm looking at a cubic and I only have 2, I'll have that same situation. Okay? So find your lead term, plot your zeros, decide if one of them has to kiss the line and not just go through it, then domain and range, and our end behavior statement. All right, good luck. Ask for any help if you need it.